Wenxiao Huang, co-founder and CEO of Feon Energy. Welcome, and the talk will be the path towards practical lithium metal batteries, first principle perspective. Wenxiao, the stage is yours. Whenever you're ready, please go ahead.
Okay, thank you. So, hi everyone. So my name is Wenxiao. I'm the co-founder of Feon Energy. A little bit, maybe background about our company. We Feon is a material company. We invent new small organic molecules as either the solvents or additives as an electrolyte to enable different future battery chemistries. We have a platform technology. We have a portfolio of different molecules we invented for different cell applications. For instance, we have two different pipeline right now. One is for lithium metal batteries, which will be the major focus today, and we also have another pipelines for advanced lithium ion batteries. For instance, for this cobalt-free cathode or high voltage cathode, also including like silicon anode. But today we will focus on the first pipeline. Okay. And a little bit of history about our company. We are a spin out from Stanford. The technology, we started to develop this technology back in 2018. Invented the first generation molecules to address the lithium metal battery challenges. Then we iterated several generations, took us about 4 years to arrive a position we believe it's at a good time to commercialization. So we incorporated about 1.5 years ago, based in Boston, and keep iterate out on our molecules design. And then right now we are shipping pre-A sample cells, about 5 amp hours to customers. And we also scaled up to the production of our proprietary molecules. Our cell right now is received the UN 38.3 certifications for those 5 amp hour lithium pre-A samples. And we just reclosed our seed round financing. Okay. So the grand challenge, excuse me. So we believe the grand challenge for the battery industry, especially for the battery for electric vehicle, are two things. The first is cost reduction and the energy density improvement. But the fact is, in the past couple of years, when we look at the cost and when we look at the energy density, they basically plateaued since we're approaching to the theoretical limit of the lithium ion batteries. Um, one technology we can address this, well, I would say maybe one of the most promising technology is something called the lithium metal batteries. When you put the lithium metal batteries in contrast with the existing commercialized lithium ion batteries, no matter it's LFP chemistry or NMC chemistry, the lithium metal can provide 70% higher in energy density. And if we translate that into different application scenarios, for instance, like electric vehicle, if you're looking at the battery pack with the same weight, you can almost double the driving range. You can drive almost 700 miles per charge and double the mission time for cell phones or drones. And another application we are very passionate about is electrified aviation, because right now the battery just way too heavy, and you can just put a very limited number of passengers into the vehicle, and as a return, you have a pretty high operating cost. But by replacing the lithium ion battery with a lithium metal, you can reduce the weight of a battery pack and put more passengers into it, so you have a much lower operating cost. And the reason the lithium metal, why it's so great, why it has such a huge improvement over lithium iron, right? So maybe I would just, even though maybe this is a little bit redundant, but I want to emphasize on the maybe basic structure of lithium ion batteries. In general, you have four components, right? You have the cathode, namely which can be different chemistry, can be NMC, LFP, LCO, or etc. Then you have the anode. Normally, it's made from graphite or graphite silicon composite. Then you have a separator in between, and but the thing is, when the batteries are manufactured, all the lithium is actually just in the cathode side. The anode, the graphite, is basically an empty host. When you're charging the battery, the lithium travels to the empty host, and when you're discharging, it comes back. So the difference in the lithium metal battery is that we replace the graphite anode completely with the lithium